Hello everybody, welcome to this new Pix4D webinar. Today I'm going to talk about DJI Vision, Phantom 2 Vision, as well as the Phantom 2 with GoPro camera, and about, of course, the application that we recently released, actually just yesterday, which is Pix4D Mapper app, specifically for DJI, that allows you to control your DJI and take the perfect flight plan that allows to get a very good map and 3D model out of it. So today we're going to talk about quite many different topics. We will start with the Pix4D Mapper app, what it performs and how you can actually use it by detailing step by step how to really use the new interface. In addition, I'm also going to discuss what is behind the app, what is really doing, what's the magic which makes it work, and also which drone we are supporting now and also in the future. Then the second part of this presentation is going to be mostly focused on Pix4D Mapper processing, how to, once you have the images, get the best 3D data out of it. So I'm going to show step by step how to start a project from the app. You control the flight, you get then the imagery, which goes back on the phone, you plug it in the computer, which will then, you will use the images to start the processing. I'll give also a small, very, very short, I promise, introduction on photogrammetry, which gives you a little bit of hint of what's possible to do with this type of technology and what not, but mostly links to other webinars which are talking more in details about it. Then something I think which is going to be of very, very big interest is we performed some accuracy testing on the solution of the drone together with the doing some measurement on the ground and compare how accurate you can, what type of accuracy you can achieve, and also introduce a little bit to quality control and how to improve the results. So that's a lot of subject we're going to touch. As usual, feel free to type the questions in the chat box. We have the support team nearby who can answer in real time to your questions, and I also pick up the most relevant questions to answer directly. So as this is usually always the most asked questions, can viewers get a copy of the webinar later to refer to? Yes, we are recording every webinar we are doing and we are uploading it to our YouTube channel as well as linking them in our support webpage. All right, so let's get started with this ambitious program. So the first question that I'd like to answer a bit is why the app? Why did we bother to make an app? Well, the answer is in two steps. The first one is for accurate 3D modeling and 2D mapping. It is critical, really critical, to get a flight plan with a very systematic overlap. Images, as I'll explain it in the whole course of this presentation, really need to have a lot of overlap on the ground to be able to do image processing, which is all what Pix4D Mapper is about. So flight plan is critical, and we make sure that with our app, we make the most optimal flight plan, which is adapted to the camera, to the drone, and to the requirements of accurate mapping. In addition, Pix4D Mapper app is also taking care of the geotags, meaning the relationship of the GPS when each image is taken. If you use the default DJI Vision application, which is on the App Store, you'll get very, very bad accuracy of geotags. But this is not because the copter has a bad GPS. It's because the geotag is not well written inside of the images. So this is something that Pix4D Mapper app is taking care about for you. So in summary, which actual drone are working with the app and which one are not, but that you can also use in different ways. So the Pix4D, the DJI Phantom 2 Vision Plus and also the Vision, which are the two models with the integrated camera, do work out of the box with Pix4D Mapper app. and we definitely recommend to use this application to start to do any mapping. The DJI Phantom 2 does not work currently with the app. The reason is that the ground station, there is no ground station enabled in it. This is a separate module that can be bought, and we're investigating right now with DJI if there is a possibility to also then control with the app the Phantom 2. But for now, it is not possible. So what you'll have to do if you have a Phantom 2, you'll have to emulate what we are doing in our flight plan. So I'm going to give the best practice about what flight plan is doing, and you can try to use it together with a GPS tracker that you can get from many different brands. And this way you can get something very similar to a Vision or Vision Plus. I already see this question asked about the DJI Inspire 1. So keeping the suspense. Right now, no, it's not. The SDK does not currently, in the next weeks, support the app. So this will take a bit longer. We are working also together with DJI to make sure that we can get also the Inspire 1 working with our app. But right now, it's mostly the DJI Phantom 2 Vision and Vision Plus. All right, so let's go into the application. So we developed this application and we launched it right for Android right now. As I also already see that some people are asking questions about iPhones. Yes, we are planning to release the iPhone version of the application before the end of the year. So give us a month and there will be the iPhone application also working just the same as the Android application. So let's enter the application. This is, once you enter the application, the first thing you get presented. Grid mission, free flight, a button to convert to maps and 3D models, and a tutorial help. So the most relevant for now is really the grid mission. This is what's optimized for making the most simple fly path for you, so you don't have to worry about anything about how to fly, and to automate the whole process. The free flight is more, if you've seen the video that we published with the crane, which is a very complex object, this type of objects will be better acquired with the free flight mission, which will come in the next weeks, which allows you to really control by hand the DJI Phantom, but, and that's a very big difference, is we are keeping the GPS tags. So we're making sure that we have a really nice GPS trace following the drone, which is very useful for the processing and especially for the accuracy, as we will see at the end. So right, let's go into pushing the grid mission button. All right, so once you've pushed the grid application, the grid mission button, you are greeted with the map around you and a box. So you have on the left side, you have 3 buttons there. The first button there is to switch between satellites and to switch between street map views. To get access to the satellite data background, you need to be connected to internet. So what we suggest for now is to not connect to the drone. First, open the application. This will load the map. And only after that to connect to the drone using the Start Mission button. So let's pretend that we are still connected to the internet. Then you have the second button here, which allows you, of course, to center the map to the location of where the phone is. So once you click it, it's going to center it. You can pinch to zoom closer to the map, and you have this rectangle, which is the survey zone. This survey zone, you can move it by clicking on this button. If you click on this button, it's going to recenter the survey zone to the center of the screen. So for instance, if you wanted to shift a little bit the surface zone to the area over here, you would move the map to have this area in the center of the screen and then click on this button. In order to change the area of the place you want to survey, for that you will need to go back in the menu and to click in the settings there on the top. Once you click on the settings, you will be greeted with a way to change the width and the height of the grid. This doesn't allow you to change the altitude for now. It allows you to change the width and the height of the surface you want to survey. With the current limitation of the battery of the Phantom Vision and Vision Plus, we allow the user to make a map up to 120 times 200 meters of size. Once you have done that, you will see that the map, the survey area will be much bigger on the map, and you can still resize it, recenter it on the middle of the screen to survey a specific area. Once this is done and you're happy with the area you want to survey, by the way, make always sure to capture a bit more on the side than what's needed, because the quality of the mosaic and point cloud on the side of the area is always going to be lower than the middle because there's less overlap. All right, so once you did that, you can click on Start Mission. And there you will have a small summary of what's happening. So basically it will tell you, it will remind you which is the area you're surveying now. It will tell you at the altitude. For now, in the version that we released yesterday of the app, it's limited to 50 meters above ground. But in the coming weeks, we'll definitely make some improvement there, which will also allow the user to change the default altitude. You click on the Wi-Fi settings, which allows you to connect to the drone. So the next step is basically you have to turn on the DJI Phantom, and with that you will it will wait a little bit. You need the Wi-Fi extender to also be turned on. You wait a bit for the Wi-Fi to set up, and as soon as this is done, you click on the Wi-Fi settings that show you the name of the drone, to which you select the right one, and you click Next. As soon as this is done, you will be greeted to this new page, which gives you a few security warning, and this is to be taken very seriously. So the most important thing to remember is the application is going to take care of the whole flight by itself, so you don't need the remote control. However, we recommend really to keep it always in hand. And for the mission to work, you have to have the level 1 S1 switch, which is this one, to be in the uppermost position. Otherwise, this doesn't allow the autopilot to work. So always remember before the flight to have it on top. And while you're flying, if you see any danger, any problem, I don't know, a crane, a bird, a crowd of people, or anything like that, the way to take control back of the drone to abort the mission, the best way we recommend to do it is basically you switch down, which gives you control back to the remote control, and then you can start controlling and putting the drone in a safe position. You can also click on Abort Mission, which becomes available as soon as you are flying, and this will make that the drone will come back to you and land in the area. But for safety, we'd rather recommend to keep a manual control if something starts to happen. Of course, we really recommend not to fly over crowds of people, not in dangerous situation. It's still a beta version of the app, and as well, it's the drone may always have some issues that you may never be that can always occur in the middle. So this, and especially for our American friends, make sure about the legislation that you're flying in full authorization with your local authorities. Once you press press takeoff, you have to keep the button pressed 3 seconds, and the drone will automatically take off, start doing its mission, and come back to the place where you started the mission and land automatically. While the drone is landing, it will start downloading the images from the drone into your application. And while this is happening, the Pix4D Mapper app will make sure that when it's grabbing the images from the drone, it will put the correct geotags in it. And then the images will be stored on your phone. By default, the standard location where the image is stored is STD card/pictures/mission. Okay, so that was a pretty easy introduction to the application. So once you have the images on your phone, you need to transfer it to your computer to basically be able to process them. So depending on your phone, you can either use a USB cable, which would be the easiest way, or you can share it through Dropbox or whatever. This doesn't matter much, but basically you can take the USB cable, plug it to your computer, and copy paste the imagery in a folder. I can already announce now that we are adding very, very soon also direct cloud support for processing in the smartphone by itself. So basically, you don't have to go through a computer. You can directly, while you're in the field, after that the drone came back and downloaded the images in the phone, push a button, which will send it over to Pix4D Cloud for processing. Just to give a rough idea of what we're talking about, a mission of 80 by 80 meters or 100 by 100 meters is around 50 pictures. A picture is around 5 megabytes. So we're talking about 200, 250 megabytes of image to upload. After the uploading is happening, you have about for 20 minutes of processing, and there you get the results of the 3D point cloud, the mesh, the auto mosaic, and the elevation model. The images are also saved on the SD card. Okay. However, the pictures are not geotagged correctly because they are geotagged directly by the drone, and the geotags are of very bad quality. So we really recommend not to take the pictures from the drone, but to take the pictures from the phone, from your phone. All right, so let's now go into a practical demonstration of what I just said there. So here I have a small data set that I just took this morning. So this is about 27 images. So this is a very, very small data set. Let's open Pix4D Mapper. Let's create a new project. You better stay on Arial Nadir. Don't choose Arial Oblique. For most of the cases, Arial Nadir for using the grid mission is what you need. So just leave the option as default without changing anything. Click Next. Then you take the images that you just copied from your phone to the computer. As you can see, the software was able to recognize the camera, was able to geolocate the images and to recognize everything. So you have nothing to do there, just click next and finish. All right, so there you can see a very nice flight log and GPS trace, which basically shows how the mission was performed on the map. And the only thing you have to do left is to click on Start Processing. So for such a project, you have very likely for a few 5 to 10 minutes processing on a good computer. But to save some time, I already did it, so I can cancel this processing and show the results of these data sets. So this is the point cloud that's been computed from this small data set. So that was another data set with 50 images using the Vision Plus, and the camera was pointing towards the ground. Okay, there I have another data set. This is taken using the Phantom Vision, so not the Vision Plus. So this is with the big wide camera. And there, as the camera cannot point directly to the ground, it's about like 20 degrees pointing to the front. So you have a bit more points on the ground, but you get basically the same things. Okay, let me go check a few questions. Is raw imagery better than JPEG? So by default, the app is doing everything in JPEG because the improvement in quality you get with raw imagery is not very, does not make a big difference for 3D processing. It's much more important to have a lot of images for the geometry calculation, but otherwise it's much easier for transferring the data to keep using with JPEG. So for there, we recommend to use JPEG imagery. Okay. So that's the very basic way of using the application and the Pix4D Mapper software. So you really just simply take the app, make a small survey, take the imagery from the phone, plug it in Pix4D Mapper, wait a few minutes, and then you get the 3D results. Now I'm going to go, for the rest of this presentation, a bit more deep into what is really Pix4D Mapper doing, what's the processing which is happening behind. So then I will go in a few topics about what to make sure for the type of terrain, what can you expect, and then of course what type of accuracy you can achieve using the Vision Plus. So here is a quite simplified way of representing what's happening in the processing behind the scene once you click Start. And it also gives me a hint about which kind of outputs you can generate with the software. So at Start, you have the original images. This is what when you download the images from your phone to your computer, this is what is given to the software. So the software is going to analyze each image one after the other, and is going to find key points. Key points are interesting areas in the image. Interesting by meaning that's a lot of contrast, places that can be easily analyzed and checked if you can find them again in other images. So here I drew only 5 key points, but a typical 12 megapixel camera is going to give you tens of thousands of key points per image. So after finding these key points, the software is going to match them across imagery. So it will basically try to see that this point is the same as this one, and this one is the same as this one. By finding correspondences between images, it's able to analyze what's the same, what's different, what has changed. And just by this, it's able to recompute the original position of the camera and the original orientation of the camera with a lot of accuracy. And this is what we call calibration step. Once you have calibrated camera, the software is able to compute 3D point cloud, basically 3D information of this area. And this is what I just shown in the software before. From this 3D point cloud, it's able to compute an elevation model, which is really a surface of the whole area. And from this, it's able then to compute an automosaic, which is a pictures, which is much better than a stitched pictures, as it's like a satellite imagery. You can really use you can do measurements. It's georeferenced. It's really accurate in for doing measurement works on it. Okay, question about. Okay, now let's just go after that. So to understand the whole workflow of Pix4D, I cannot summarize it in 5 minutes. So I really would recommend people to go watch a full webinar. Actually, we have several webinars dedicated to this topic of how does the software works and what are the implications of it. But I'll jump directly to maybe one of the most important items, which is the accuracy, which is the overlap, and this difference of overlap with respect to the different heights in the objects in the scene. So when you're using Pix4D Mapper app, basically it will take as a reference that the ground is pretty much flat. And if it's flat, it will take the distance between the images, such as there's something like 70% of overlap between the imagery. And this overlap depends both on the altitude of the drone and on how often the pictures are taken. So as a reference, using Pix4D Mapper app, when you fly at 50 meters altitude, a picture is taken every 15 meters and on the side and every 10 meters in front. So that's roughly a pictures every 5 seconds. If you fly at 2 meters per second. However, if you have objects in the scene, the objects will be basically higher than the ground, and if it's higher than the ground, it will limit the overlap which is on this object. And one of the most important things that makes the whole application and software work is the consistent overlap everywhere in the scene. So you may end up, if your object is way too high compared to the 50-meter altitude limits that we have right now, if it's too high, then you may have no overlap on top of building, and some places where you don't have enough overlap, and if you don't have enough overlap, there won't be any 3D information computed at that spot. So we will allow in a future version of the Pix4D Mapper app to change the overlap settings to be able also to encompass this type of situation. However, if you look back in the examples I just shown before, you can see that the building, even the top of the building, is seen by many images. So to give a rough estimate, here on the ground, every pixel is seen by 20 images in average. And on the top of the building, every pixel is seen by 13 images in average. So, and this building is about 20 meters high. Actually a bit less. But you can still fly even if you have tall building in the scenario in your data set. You can still, with the default setting we have put, you can still fly over pretty steep terrain. Another thing I'd like to quickly introduce is quality control. and I'm going to talk that just before accuracy. And that's an important thing, because it's not because it looks pretty, and I must say that this result looks quite pretty, that it's really accurate. And there's a lot of ways to make the software fail or to have issues. For example, everything is based on image content. So if you fly at midnight and there's no light and everything is dark and basically all your images are black, you will not have any, everything will fail, and it's not going to work at all. So for the whole software to work and to be able to get good 3D model and maps, you really need to have a nice, good-looking images, basically. And good-looking images are images which are sufficiently with enough light and which are pretty much, how to say, with enough content in it, with enough texture. So flying over ice cube, a giant ice or snow place, is not going to give as good results as flying in an urban environment. Because let's, like, for example, take this data set where you have the side of the building. Because of the sun, you can see that in many images, the side of the building is totally white because it's reflecting the whole light from the sun. And if it's fully white, then there's no possibility to compute 3D information. And that's why in some areas, like in this one, you don't have any 3D information that has been computed, because the image was saturated, oversaturated, and there was no possibility to recompute the 3D information at that spot. So now in practice, how can you do the quality control? What are the tools that Pix4D Mapper gives you? The first one is, after each processing, you get access to a quality report. In this quality report, you have at the very beginning 5 quality checks. These 5 quality checks should be, well, the most as possible green. And if they become orange, then we really advise you to click on the question mark. That's going to give you access to a very extensive help on what to look for further to make sure that the quality is optimal of the project. In addition to the quality check that you can do this way, you can also use this 3D interface that we provide, which we call the Ray Cloud. The Ray Cloud is not just a 3D viewer, it's also a full interface between whenever you click an area in the 3D point cloud, you will see the relationship between the point that you just clicked and the images from which this point comes from. And on the right, you have a toolbar which basically shows in each original images where does this point come from. This is a very, very important tool, as it allows you to go beyond simple measurements and to really get accurate results from the DJI Vision and from any actually aerial imagery. Let me give you an example, and this example I can give it to you by showing some measurements that we did in this data set and that we compared versus using a tape in the field. So we did the data sets that I just shown before. We simply took the images, put it in Pix4D Mapper, processed the imagery, and then we started to do some annotation to define some areas in the data sets. And then we compared the value that we got doing the line measurements in the software versus going out in the field, taking a tape, and measuring the distances of the different objects. So you can see that we did some of the roof, the solar panel here, a big one, a small there, and also 2 further there on the ground. And then we tried to see what is the difference between what we measured in Pix4D Mapper and what we measured in using a simple tape. So basically, the conclusion of this is that in most of the case, our measurement that we did were around 1 centimeter in the same range as the tape measurement we did on the ground. except the M1 over there, which was done with which had 3 centimeters difference. And this is this makes a lot of sense, and these are type of accuracy you can expect from using the DJI Vision and our software. However, these are relative measurements. So don't expect to, if you take, however, these measurements, the map, and you put it over Google Earth, you may have, however, something like a 5-meter shift in a random direction. This is because of the consumer grade accuracy of the GPS which are inside of the DJI Vision. If you want to have higher accuracy than 5 meters in a random direction, but really something similar, centimeters, you either need to be using a drone that is equipped with RTK GPS, or to use a very precise GPS, RTK GPS, and to do some measurements on the ground, which we call ground control points, and to insert them into Pix4D Mapper, and to use them in the processing. If you take 3 points in your data set and include them in the processing of Pix4D Mapper, you will be able to achieve centimeter accuracy in the whole project. So the conclusion is you can achieve centimeter grade accuracy with the Vision, and if you need global accuracy, you will need to use at least 3 ground control points. I recommend to watch the webinar, a full webinar, which is about ground control points, to get more information about that. Now, just a little summary of the different outputs that's able to produce using Pix4D Mapper, either Discovery or Pix4D Mapper Pro. So Pix4D Mapper Discovery is the free version that's available on our website, and it allows you to do 3D animation and single point measurement. So let's see in practice what this means. It allows you to process and get this type of results, as well as, let's click on this tool. Record a 3D movie that you can then play back and save as an MP4 file that you can then distribute and upload to YouTube. The other thing you can do is to go at any location of your model and click on a point, and you will get the 3D coordinates of that point. Now, if you're using Pix4D Mapper Pro, you are able to actually output a lot more different formats of all the different possibilities. So one of them is the possibility to do volumetric measurements. So if you have Pix4D Mapper Pro, you can create a volumetric measurement, go around, for example, this area, and by clicking on it, you can then directly compute that you have 12.7 cubic meters in this area. Thanks to the very, very high precision that we have, this measurement is extremely accurate, and you can be sure that you are within a few percentage of the the real truth. This is especially useful in mining environments and construction environments. You can also use, if you want to know the surface of the solar panel, we have also tools for surface annotation. That gives you lots of different type of measurements on the area and the surface that's taking account. As I was saying, you are able to go further into simple accuracy measurements. So this is a table, but you can see that if I had to choose which point to click on to measure the size of the table, it would be pretty difficult. So this is where the ray cloud commits full power. So you start by doing an initial guess, and then you can use the images to refine your initial guess into a very, very precise measurement by clicking, by helping the software to go exactly on the border of the bench. You see in lifetime the reprojection of the measurement you just did over all the images, which allows you to get a confirmation on how accurate was the measurement you just did there. By applying, you get now the real estimates of the lengths that you just measured there. Of course, if you have Pix4D Mapper Pro, all the measurements that you do are able to be exported into AutoCAD and shapefile for ArcGIS and any GIS software package, as well as KML. You can also export the point cloud as a LES point cloud. And in many different formats. And you can also generate, of course, auto mosaic, which is actually automatically generated. And not only is the auto mosaic generated, but you can also use the mosaic editor, which is loading right now, to enhance and improve the auto mosaic that you create. We also have the possibility to edit the point cloud, and to improve the 3D model, you can always select a bunch of points. Oops. And delete them. I'll also show right now a quick glimpse of a new feature that's going to be available very soon in the next weeks or months, which is also now the possibility to generate full 3D mesh, textured simplified 3D mesh from the datasets. So this is the same dataset we just saw before, but displayed as a simplified textured 3D mesh. Of course, there are many other things you can do in the software, which I'm not going to go over right now, like contour lines, elevation models, and index calculator, also with infrared imagery. But there are plenty of other webinars which are tackling these different points. Maybe I'll just finish before going into the questions. A last slide about how to improve the results. So if you need to cover larger areas and to also have better sensors, which will improve a lot the quality of the 3D model that you will get, then we definitely recommend to use to check out all the partners drones that exist, which have very good flight planning software and that have possibilities to have improved cameras also on it. There, as a hint also, we have plenty of ways in the Ray Cloud editor to add manual tie points, ground control points to improve the accuracy, as well as doing point cloud editing and surface editing to improve the size of the objects and to start doing digitization and surface editing, and also as well as the mosaic editor. All right, now let's check. I spend the end of the webinar as a discussion with the questions which have been asked during the length of this webinar. Will you release a Mac version of the desktop app? So we must say that we've got more and more requests about it. So as a hint, this is definitely something that our engineers are already working on. So I don't have a release date, but we are working on a Mac version of the desktop app. So this is coming soon. Just before that, there will be the cloud version, which will be usable directly from the phone. So you don't even need to use a desktop computer to generate your 3D model. What are the minimum number of geotagged photos required for an accurate model, and can a model be created without GPS info for testing purposes? Yes, it's perfectly possible to just put images into the software and to try it out like that. And you can use the software without any geotags. It works, but it's really, really not recommended because it's going to be slower, it's going to be of lower quality, and it's not going to be georeferenced. So if you have the possibility to geotag your images before, we really, really recommend, as it gives a lot more power in both quality control and also results. What camera uses the Phantom? So the Phantom has, the Phantom 2 Vision has an integrated 12 megapixel sensor in it with a fisheye lens. The fisheye lens is something very, very good for low altitude mapping because it allows to capture much wider area. So we really recommend this type of cameras, and that's why the Vision works also so well for low altitude, so something between 30 to 50 meters altitude. What can you export with the free version? So I just explained before. You are able to export the movie that you do as an MP4 file, as well as to make single point measurements. Then you can rent Pix4D Mapper Pro, in which you can export automosaic, elevation model, point clouds, annotation, and every measurements you do. Where can the Pix4D map be exported, like SketchUp or something like that? So we generate also 2D maps, and maybe let me show you an example of this. Support.pix4d.com. DJI. So we have a partnership together with a company called Mapbox, which allows you to publish your 2D maps online. So whenever actually you get a license of Pix4D Mapper, you also get access to Mapbox with a special discount to be able to publish your 2D maps. So as you can see, the maps there on the bottom, this is a vineyard that I mapped the other weekend with a very steep elevation. And this was done using the app, and then generated the automosaic using Pix4D Mapper, and that was then published using Mapbox with the direct link we have inside of our software. For using, what's really important to know is all the data we do is georeference, so it has geodata, which means that it can be very well imported in any GIS type of software, like QuantumGIS, Global Mapper, AutoCAD, ArcGIS, and so on. Can you export to LAS format? Yes, it's possible to export the point cloud to LAS. What can I do with a GoPro camera? Or is it necessary that the camera of the Phantom Vision Plus? So the GoPro camera is a better camera in terms of picture quality, especially the GoPro Hero 4, which has really a very good picture quality also with respect to vibrations. However, as it's not integrated inside of the UAV, you will only have the images and not the GPS tags together with it. So as for right now, we really recommend to, and we cannot control the rate of captures and so on. So you will have, if you just have a GoPro and you take images, it's going to work, but it's going to be harder to do quality control and to have a very nice consistent overlap between each images. So we do not, we really recommend right now that as an easier solution, that you are more certain that it will work every single time, to use the DJI Vision Plus with the integrated camera than to try to have a GoPro on top of a drone. Unless you have a specialized drone which is able to also geotag correctly each images. After you convert the point cloud into a 3D mesh, how do you generate the texture? So this is an upcoming feature of Pix4D Mapper 1.3, which is going to come before the end of the year. So stay tuned for that. Any conflict with DJI remote Wi-Fi for Phantom control versus phone to Phantom for mapping. So if you use a remote control, to make sure that you can use the autopilot, you have to put the switch S1 on the top position. And anytime you want that the remote control takes over the position of the drone, you simply put the switch down. So let me go further questions. Which DJI 2 Plus at 50 meter with the best resolution? How many centimeter pixel? Okay, so the project that I just showed there have a ground sampling distance of, in average, 2 centimeter per pixel. So each picture that you see there have each points were generated with a 2 pixel resolution, 2 centimeter resolution, which is pretty high. On the top of the building, it's even higher since you are closer to the camera. How is the process of the geotag? Has the DJI an internal GPS? Yes, the DJI has an internal GPS that allows for stabilization. And we also use this data to geotag the imagery. Okay, is the camera always need to be tilted to the down, or can you tilt it to the side to take the side of a building? So this is exactly what will come very soon with the free flight mission, the button which is written coming soon, which will allow you to tilt the camera to take really the side of a building, like for the examples that we showed during the demonstration of DJI. Is it possible to use ground imagery as well as DJI imagery and put them together? Yes, it's perfectly possible. And you can, for example, take a GoPro, go inside of a building, do the interior 3D reconstruction, and then take the DJI to do the outside, and to have an outside and inside 3D model. The webinar of last month was exactly on this topic. So you can have more information by watching this webinar. Areas AI desire to map do not have self-service. Is this a problem for mapping? No, it's not. So we don't need a cell phone connection. We don't need data connection to do the 3D mapping and to use Pix4D map. What we are going to introduce very soon is the possibility to pre-catch the images. So when you have data connection, you can pre-catch an area to have the data of the map saved without data connection, and then when you're doing it, you have the background map that still show nicely. Is it possible to change the altitude during the flight? So for now, not. We are trying to keep it simple as possible to get everybody able to map in an easy way. And for that, we are keeping a constant altitude during the whole map. So either you can override that using manual control, or this is also something that we plan to support in the future of the app. This is mostly important when you have areas with very different shapes, like hills, or when you have tall buildings and lower buildings. But as you can see from the demo of this data set, it also works very well even if you have quite tall buildings in your data sets. Alors, Which is the best camera to work with Pix4D? That's actually a very good question. What's the influence of a camera for 3D mapping software? Well, of course, the better the camera, the better the results. So if you have a really, really huge camera with excellent lens and excellent everything, the quality of the results will be better. However, and that's very important also to notice, is not that much better. A bit better, but not that much better. Actually, if you fly 10 meters closer to your objects, you will probably get much more, even with a much smaller camera, you will get much better 3D results than flying further away with a huge sensor. So that's also one of the reasons why the integrated sensor of the Vision Plus is doing quite pretty well. What matters the most is the overlap, the consistent overlap between the images and being quite close to the objects. So this demo was, what was the altitude for this demo? It was about 50 meters altitude. So the Pix4D Mapper app is now programmed to fly by default at 50-meter altitude. Okay, will it work on other DJI copters, such as the NASA with the Zenmuse and so on? So I'll just give a hint because I cannot promise anything there, but we are working with DJI to make sure that we can then reuse the SDK and then our app on all of the different DJI products. So also, what was the approximate time of computing? To compute this data set, it was a actually it's pretty small data set. It's only something like 50 imagery. On this computer, it took 9 minutes for the first step of calibration, and then it took another 7 minutes for doing the densification, the point cloud densification. So, and then you have the results that you see there. Can you change the units of measurements for metric? That's a very good question. Yes, you can change the units after the flights by going into select output coordinate system, arbitrary coordinate system, and then you can switch to feet. If you add pictures from the ground using a big SLR camera, and can you add this to the drone imagery to get better building pictures? Yes. As mentioned before, it is possible, but it's quite an advanced topic. So I would recommend to watch the webinar that we did 1 month ago, which is exactly on this topic. All right, so that's been a lot of questions and a lot of a very interesting webinar. That's I thank you very, very much for the attention and for attending this webinar. So thank you again very much. I hope that you got a lot of information and that you will have a lot of pleasure using your DJI Vision and Pix4D Mapper app. We'll do another webinar next week on Friday about the same topic for people who could not attend because of the limited audience that we cannot have more than a few hundred of people at the same time. So thank you very much. If you have any question, please feel free to contact our support team to watch the knowledge base where we are adding more and more articles. Make sure also to check the updates of the Pix4D Mapper app, as we are now going in the next weeks to make a lot of updates to improve the lots of options and possibilities of the app. And well, thank you again, everybody, for watching this webinar, and I hope to see you again for a new one. All right, see you soon and have a great day. Bye.